So another way these can show up would be something like the following. So this one's actually going to be fairly similar to the first one, except the formula for the terms of the sequence is going to be embedded right into the sigma notation to combine everything together. So here's what I mean by that. You could compute something like the following. So let's say I wanted to compute the sum from I equals 0 to 4. So you can see it's incomplete in its current form, but you can see already right away you know three things. You know that I is going to be the letter used for the index. You know that its initial value is going to be 0. That's the value it starts at. And then you also know the value that the index will terminate at, which is 4. So you know that your indices are going to be the 0, 1, 2, 3, and 4 that you add up the terms for. So what are the terms going to be? That's the part that belongs here. So to fill that in, we're going to say that the terms are given by I cubed. So this is the expression that's being added up for the values of I, which start at 0 and end at 4. So what would that look like? Well, let's work it out. So the sum from I equals 0 to 4 of I cubed, that's just what we're evaluating, so I haven't done any work yet. But the first step is going to be to actually unpack this sum. So start with your first value of the index and plug it in, and you're going to get 0 cubed. And then increment your index to get 1, plug in I equals 1, and you'll get 1 cubed. And if I keep on going until I get to 4, what I'll end up with is plus 2 cubed, plus 3 cubed, plus 4 cubed. And then that's when I stop, right? Because 4 is the final index. So this is going to be what our sum evaluates to. Now let's evaluate what each one of these individual terms is now. So 0 cubed is just 0. 1 cubed is 1. 2 cubed is 8. 3 cubed is going to be 9 times 3, which is 27. 4 cubed is actually 64. And if you add all these up carefully, use a calculator, stack them, whatever you want to do, you're going to end up with exactly 100. So that's what this evaluates to. It evaluates to 100.